Hello and welcome to another edition of Design Spark Ask the Expert. Today we're going to be talking about IO Link and what that means for automation. Automation and industrial control has undergone many changes over the last couple of decades. Recent things like the Internet of Things and Industry 4.0 are seeing this change. One of the key components for the industrialization and the Internet of Things is IO Link technology. And today I've got Miloš Hoffman from ST Microelectronics to talk to me a little bit more about what IO Link means and how ST Microelectronics are approaching IO Link for their customers. Hi, Miloš, would you like to say hello to Design Spark?
Hi, I'm Miloš. I joined ST Microelectronics many years ago as an application engineer. Last 10 years, I work in the marketing. I'm in charge of vertical factory automation program in Europe. And my key focus are input and output peripheries in automation systems and IO link communication for sure. I'm located in Prague in the Czech Republic.
Great. So, Miloš, obviously, what we were saying in the introduction there with industry has overgone quite a lot of change in the last couple of decades. You know, it's always changing. And one of the things that intrigue me about Industry 4.0 and the Internet of Things is the communication of those. So within existing, factory automation and installations, you've got many different types of communication. You've got existing field buses, for TNS, Ethernet for communication. What is it that IO Link brings to the offer, which maybe those previous legacy kind of communication networks didn't?
Sure. IO Link is developed since the beginning for communication at the lowest level in automation systems. Therefore, it's perfectly optimized for that purpose. It differs from field buses you have mentioned in many aspects. IO Link has point-to-point topology compared to the multi-point topologies of field buses. It consists of a master on one side and a device on the other side. IO Link is primarily designed for a regular process data exchange where the information is quite limited in size, so typically just few bytes. Let me show you in one animated example how the IO Link operates. Just a second, I share my screen quickly. Let's consider a system consisting of several sensors and actuators on the bottom side. Then an IO Link gateway in the middle connected through field bus to a programmable logic controller, or let's say PLC. And this PLC has also some IO Link expansion modules with IO Link master functionality connected to the industrial Ethernet and accessible on the enterprise level. We have selected a pressure sensor, then a kind of multi-parameter device like conveyor system, and a temperature sensor. Let's see how the communication among these devices and their master may look like. We can transfer just a simple process data from the temperature sensor. Or we can access also diagnostics together with the process data, like here at the conveyor system. If needed, we can read also parameters together with process data, like displayed here. And we can update also configuration of the device, again, together with the process data exchange. And at the end, the master can request also diagnostic information. So as we have seen, the process data are transferred every communication cycle. In addition, to the process data, the master may read parameters, access configuration, or get diagnostic information at the same communication cycle. Through this mechanism, the process data are sampled and transferred with a constant period, which is very important for the control loop. Mm-hmm. So finally, let's come to the benefits. As we have seen, IO Link extends the digital communication to the last meter in the factory, and therefore it supports digitization in automation, which is essential for Industry 4.0 megatrend. It enables to transfer additional information like parameters, configuration, and diagnostics, as we have seen. One of the great advantages of IO Link is possibility to use the existing infrastructure. So because the requirements are quite basic, it enables to replace the field devices without changing the wiring in the factories. IO Link is also, from the operating point of view, fully backward compatible. So it means that every IO Link master can interface the conventional binary switching device, and every IO Link device can be connected to the digital IO port of a control unit. So IO-Link is independent from any field bus system, and its implementation is very cost effective. And we would find for sure many more advantages.
So there are quite a lot of advantages which you've explained there. So we're moving now from within the industrial Internet of Things for Industry 4.0, for example. It's really key to actually get the data points. And as you mentioned there, from the sensor level, that last meter, which has always been the issue about how do you get data from the devices that are in situ up into the control level. So IO-Link expressly helps to do that. But not only the process data, also the diagnostic data as well. So you can actually then start to monitor and look to improve. You can maybe look to do kind of some maintenance around that if you're looking at process data and define improvement points. I think
Definitely.
one of the other thing that you mentioned, which is key for me, is that the IO-Link, when we perhaps think of the industrial environment, sensors will be knocked or banged against with crates or boxes, and they can become damaged. So now it's just simply a case of replacing the sensor. You don't need to do anything else other than replace the sensor. The system using IO-Link takes care of all the parameters already set up. Is that correct?
Yes, that's correct. All the parameters are stored in the master, and the replacement of the sensors is very straightforward. That's also a key advantage.
Yeah. So for users, obviously, you're in a high pressure situation where you've got conveyor system or a process line, a sensor goes down, a quick, simple replacement, and there's very minimal impact on that system. Yeah, great. So
Exactly.
Milos, could you just tell me a little bit about more of the ST Microelectronics offer for IO-Link systems?
Yeah, sure. ST has a broad range portfolio, as you know for sure, and therefore we can cover many building blocks of these systems. So we have rich offer on microcontrollers with a different ARM Cortex cores, starting from entry-level, low-power, mid-range, up to high-performance lines. And we have extended also this offer recently, even by microprocessors. So that's the new field for us. We can offer a wide range of sensors also in a form of microelectromechanical systems, so called MEMS, where you can find many different devices like accelerometers, gyroscopes, magnetometers, inclination, pressure, temperature, vibration sensors, and many more. We are also combining several sensors in one package, like for instance, accelerometer, gyroscope, and magnetometer in our iNemo inertial measurement unit. And besides that, ST offers many discrete components, protections, and power management products, and many more. I'm sure I forgot many. And finally, coming to the IO-Link interfaces, we offer solutions for both, for master as well as for device sides. And for master, we can propose our L6360, which is the master transceiver. And for devices, we are proposing L6362A and the brand new L6364, which we have introduced on the market really very recently.
Okay, so you offer obviously discrete and integrated circuits enabling the build up for IO-Link master and device nodes. If, say, for example, customers were looking for help during the development period or want to find more information, do you have things that you can help with, like application development advice, for example?
Yeah, definitely. Very good question, Greg. Let me comment a bit more on this. There are different possibilities how to help and how to speed up the product or even a concept evaluation at the customer side and their application development. ST designs evaluation boards for and different device kits for every new integrated circuit, basically. And we have also different types of that evaluation boards. Many of them are more product oriented, enabling customer to evaluate product features, electrical parameters, and to test its performance as a product level, basically. But besides that, we have also system-oriented designs enabling our customers to build up even more complete blocks with functionalities which may be really very close to their final product. And I think that's also important part of our offer, which helps to speed up the development of the final applications.
Great. So a lot of obviously engineers, technicians are looking at the hardware side, and it's great. We have the offer of the hardware and the products, but behind that, what is it that ST can also offer in terms, say, of software?
Clear. Yeah, our priority is definitely to serve our customers as well as possible, and to ease their work during the evaluation and product development. And therefore, we provide complete tool evaluation tool packages, including software libraries and demo applications. So, because the hardware without software is a bit limited offer, as we understood. When we talk about IO-Link, for sure, very important part of the system is the IO-Link communication software stack. We offer our own mini stack library for a concept evaluation with our newest IO-Link device chip. And besides that, we have a partnership with the company TE Concept, which is well known within the IO-Link community and provide professional communication stacks. And they are ready to use for all of our STM32 microcontrollers, but also other platforms, of course.
Okay, so that's really interesting. That you obviously you're working with TE Concept. We will probably put some links to that at the bottom of the video, so our users can then go and find a lot more information around that. But in terms of the your IO-Link transceivers, when we're obviously talking about IO-Link, a lot of people will naturally think industrial application, noisy environment. So what is it that you can position about your IO-Link transceivers?
Yeah, okay. Let me start from the master chip. Our L6360 is a compact single-channel transceiver with embedded power stages for communication as well as for device application supply. It integrates also additional digital input channel, user LED drivers, and voltage regulator. Many parameters are configurable over I2C interface. As it is a single-channel IC, it fits basically any master application. So now coming to the device side, we have two options here. Either a very simple but a very robust chip called L6362A, which is a bit longer time in our offer, or the most recent and highly integrated L6364. The first one has the most efficient power stage on the market. This is what I would underline. I mean, it has embedded switches with the lowest on resistances. The newest one, L6364, is a dual channel IC with many advanced features and rich diagnostics. Its product stages can be operating either independently or you can connect them together in a join mode, so-called join mode, for efficient driving of output currents up to 500 milliamp. This one has also integrated M sequence management with automatic checksum calculation and verification engine, which simplifies definitely the work for the microcontroller in the application. It also integrates power management circuits, and many features of that chip are configurable over SPI bus.
Okay, so you can actually build in more functionality and configure as you want. The good thing that you mentioned there as well was about power management circuitry as well, which is always very handy to be aware of. I was talking just previously, I mentioned, the industrial environment and where products will be ultimately placed. So what is it in terms of what you would offer against maybe EMC, surge protection, pulse? Do you have to consider external components to mitigate against those types of things?
Good point, Greg. In the industrial field, this is a really critical point, and EMC immunity is one of the key parameters. This is what we understood and we have experience with, and therefore both of our devices integrate reverse polarity and EMC protection circuits. So these EMC protection circuits include also protections against high energy surges, which are not so common, I mean, on the market. This is definitely one of the key strengths of the product. And for the customer, it means at the end, high level of protection in the application and external component savings.
Okay. Obviously, with application, there comes a question of interoperability. So in terms of your products, how well do they fit with products from other or components from other vendors, for example?
No worry at all from this point. Compatibility is ensured thanks to the IO-Link test specifications, which must be fulfilled by each vendor. And besides this, there are even dedicated interoperability meetings, which are organized by the IO-Link consortium. So the application's compatibility is checked also in praxis, even before the market release. So it means our device applications are fully compatible with any IO-Link master and vice versa. So you just need to use the right IODD file included in the firmware package and load it to the master. So I've mentioned IODD file. Maybe I should explain what it means. IODD is IO device description, and these files are available for every existing device. So each vendor, when he wants to put IO-Link device on the market, he must deliver it, including the IODD file. And these files are stored also on the centralized database and accessible through iolink.com web pages. So everyone has really access to all the description files for all the devices. So let's say, I would say from this point, and thanks to this strategy, is the interoperability really ensured and makes no issues.
Yeah, that makes a lot of sense. That strategy. It's really good to hear that. One of the other things I know we've had questions around, and maybe you could just expand on, is IO-Link certification.
That's a good point, yeah. And in this case, the strategy is also specific, I would say, because in fact in IO-Link we do not have any real certification necessary for the products. So the responsibility is left up to each manufacturer to ensure the full conformity in accordance to the test specifications which are defined by the IO-Link consortium. So each vendor is responsible for his devices and masters which are going to be released on the market, just need to perform the tests which are specified in the test specifications, and that's all what needs to be done. Yeah.
Okay, so what we're saying then is, as the product's on the market, you can be satisfied that the IO certification exists for that product, correct?
Yes.
Absolutely, great. So there's a lot of information, obviously, about IO-Link and the application of IO-Link, as we mentioned earlier. You know, it's one of the things which is helping to drive maybe the smart factory and getting information from sensors that previously were hard to get to. But what is it you can offer customers in support? How would they get access to support from ST Microelectronics?
Yeah, sure. We provide customer support on our products and tools. That's for sure valid fact. And there are several ways how to get in contact with us. So this goes either directly through our engineers in the field, or through our distribution partners, or even online on st.com. A customer has the possibility to get in contact with our support center, and even the questions are time to time arriving even to us personally. So there are many ways, and we encourage for sure our customers to not to hesitate and try to use any of that options to get in contact with us.
Okay, great. So Milos, we've covered quite a lot of ground already about IO-Link, and probably just before we finish, I'm just going to, you know, ask you to summarize why you think IO-Link is really important. What advice would you give to somebody who is maybe considering IO-Link for a project or a kind of upgrade within their facility? And would you also agree that IO-Link is one of the key ingredients to delivering a successful Industry 4.0 strategy?
Okay, good. Several questions in one. So let me suggest to display again another nice animation to show you the effect of cost savings thanks to this technology. So just a second. Let me share the screen with you. So let's consider once again a control system consisting of a PLC on the left side here, and some input and output modules here on the right side, which are connected through field bus. And as we usually need to sense and drive both signal types, I mean analog as well as digital signals, we need to install in the field several module types, I mean analog as well as discrete or digital, as it is called here. So we talk about analog input modules, analog output modules, digital input modules, digital output modules. So several different types. And moreover, several channels on each of that modules installed in the field are maybe unused at the end. And this is very inefficient, definitely. So the situation changes completely when we use IO-Link. So let me show you. With the IO-Link, all the 4 different modules can be replaced simply by just one IO-Link gateway.
Mm-hmm.
And that gateway has a master functionality with several ports. I display 8 ports on this picture. And thanks to this, we can simplify the installation in the field really significantly, and we reduce the variety of stock articles and the overall cost at the end. So let me comment also the second part of the question. Would I suggest if somebody is going to develop an IO-Link application? So if you are going to develop a new product with IO-Link interface, please take a look at ST product portfolio. You will surely find a major portion of your bill of materials and the functional blocks you need to implement. Get evaluation kits and download the software to speed up your development. So this would be my advice. And the last point, if I'm not wrong, this was related to the Industry 4.0 implementation. And Greg, I'm 100% in agreement with you. IO-Link is great technology. It's surely one of the major innovations in the automation IO field. And I would say even stronger, IO-Link is key enabler for successful Industry 4.0 implementation.
Great. Miloš, it's been great talking to you today. We are going to continue the conversation here on Design Spark around IO-Link. We will be looking at your evaluation kits, so people can expect to see some more information quite soon on Design Spark. But I'd like to just thank you again for your time today and explaining IO-Link in such detail.
Great. It was my pleasure, and many thanks for the invitation.